We've seen previously that when a single atom loses or gains one or more electrons, it can form an ion. So a good example of this would be a metal like sodium that has 11 electrons, losing one electron and forming an ion that has 10 electrons, and 10 electrons gives it an electron configuration just like neon. Similarly, a non-metal, say something like fluorine, can gain an electron. Fluorine has 9 electrons, so when fluorine gains an electron, it becomes negatively charged. It ends up with 10 electrons, just like neon. It doesn't have to be just the one electron, it can be multiple electrons, 2 or 3 electrons even. So a good example of this would be aluminum, which likes to lose 3 electrons. Starts with 13 electrons, ends up with 10 electrons. Again, just like neon. Doesn't always have to be like neon, just happens to be the examples that were given here, but the ion always ends up with a noble gas configuration, or it could be something like oxygen, which gains 2 electrons and forms the O2 minus. So you get the idea, okay? And oxygen begins with 8 electrons, and after gaining 2, again ends up with 10 electrons, just like neon. So these things that we're talking about here are what we call monatomic ions. They're just a single atom that has lost or gained some electrons. What we're talking about in section 3.6 are polyatomic ions. And polyatomic ions are things that have an electrical charge, that's why they're called ions, that are composed of multiple atoms. So a polyatomic ion is formed from a group of atoms that are held together by a thing called a covalent bond, or by multiple covalent bonds perhaps, that has lost or gained one or more electrons. Now we're going to have to define this a little bit as we move through chapters 3 and 4. So we've got this group of atoms that are held together in some way, and then because atoms are neutral, that group of atoms will be neutral, but then this group of atoms is going to either lose or gain some electrons. So there are a few polyatomic cations, positive ions, and the most common one is the ammonium ion. This one we're going to see a reasonable amount. And then the second most common one is the hydronium ion, which we'll see a little bit, but not much. And then there's a pretty rare polyatomic cation, the mercury 1 ion. Okay, so what about anions? Well, there are many polyatomic anions. Here's a handful here. So yeah, these are the guys. Now, you can see here they all have a formula, they all have a specific charge, and they all have a name. So this can be quite daunting to learn all these formulas, charges, and names. In general chemistry, we're expecting you to know this list of 10 formulas, charges, and names. For you guys, all you need to do is to bookmark a page that has a list of common polyatomic ions, their formulas and names, and then you can have that at hand when you're working through your assignments. So we're going to use these polyatomic ions when we're writing the formulas of ionic compounds. So I could have the compound formed between the ammonium ion and the chloride ion. It's called ammonium chloride. There we go, like that. So the same general rules apply. We need to make sure that our final compound is electrically neutral, and we always write the cation first. So it's really just like working with any other kind of ion. So if I had something like this guy, I would need to do crossover, and that's telling me that I'm going to need 2 nitrates for every 1 calcium. But the secret here is that when we have multiple of a polyatomic ion, we put it in parentheses, and then we put the multiplier outside the parentheses. Now, earlier on I had mentioned the idea that ionic compounds always start with a metal but now what we can write is, but potentially also they can start with a polyatomic cation. We could put or NH4, right? We can see that now that that's a possibility. Okay, so that concludes this short video on polyatomic ions. Some of their formulas and names were given. You should bookmark a list of that. And we also explained how we write the formulas for ionic compounds containing polyatomic ions. Hope the video was helpful.